This is video 6 for Unit 5, and in this video I'm just going to talk about circular motion, and we've talked about circular distance a little bit when we were talking about arc length. And so this will be similar, except we're talking in terms of two different types of speeds. One is going to be angular speed, and the other is going to be linear speed. And if we think, you've done problems with speed before, thinking about distance equals rate times time. And rate is equal to distance over time. Well, the same is going to be true here. If we think about, and again, let me just draw a circle here, and we think about going through some angle measurement or some degree of rotation, and S we think of as circular distance. Well, linear speed is more equal to the familiar of what we know as distance over time. And for a circle, we talked about circular distance being that arc length. So arc length over time. Well, for the other type of speed we're going to talk about is the rate at which the central angle is changing over time. So angular speed is equal to how much of an angle I've gone through, how much rotation over time. And angle speed is usually denoted by this Greek symbol, omega. The key, however, here is this angle must be in radians. Well, these two different types of speeds are actually quite related, because if we think about going back to our definition of radians, remember radians is equal to S over R. So, and that means that the arc length is equal to theta times R. So if we go back to our linear speed is equal to, we said, the circular distance traveled over time, but replacing S with theta times R, we get the following, which is just the same as theta over t times r. Again, theta being measured in radians, which is just our angle speed times r. So this is just angular speed times r. So if we have the angular speed, then all we need to do is multiply by the radius to get our linear speed. So a lot of these types of problems are going to be involving some conversions. So let's do a example together, and this is from the 5.5 packet on circular motion. So Trip is riding a bike. This is the first practice problem. Riding a bike with wheels 26 inches in diameter. All right, so let's do, this is problem number 1 on the practice. So 26 inches in diameter means our radius is 13 inches. If the wheels rotate at 125 revolutions per minute, so this is giving angular speed in revolutions per minute, so 125 revolutions per minute. Find the speed at which he is traveling in miles per hour. So we want miles per hour, we want distance over time. We're talking about linear speed. So the linear speed, and again, the goal is miles per hour. So we're going to have to do a bunch of conversions. Remember, linear speed is equal to angular speed times radius. And we do have the angular speed, it's just not in the units we want. So we've got 125 revolutions per minute times our radius is 13 inches. Again, not what we want. We want miles. So we're gonna have to do a bunch of conversions. Okay, let's deal with the revolutions per minute first. We'll deal with revolutions. So we know one, oops, I want to get rid of revolutions. So we know that, there we go, that 2 pi radians is 1 revolution. So that'll change the revolutions to radians. And then let's deal with the minutes. We know that 60 minutes is 1 hour. So that will deal with our minutes. And now let's deal with, we got to get inches into, into miles. So first thing we're going to do is 12 inches is 1 foot. And then 1 mile is 5,280 feet. So just a bunch of multiplication division. And notice we're having the units that we don't want canceling, replacing it with the units that we do want. So inches here got changed, and then we changed feet to miles. So our final answer is going to be in miles per hour. So putting this in our calculator, we get 9.67 miles per hour. Again, just doing a bunch of conversions there. Let's talk about, maybe let's do 3, and this is in the practice problems, a ceiling fan. So this one we did practice problem 1. This next one we'll do practice problem number 3. All right, so you've got a ceiling fan with 16-inch blades, rotates at 45 revolutions per minute. So the radius we have here, so the radius is 16 inches, and we've got our angular speed is equal to 45 revolutions per minute. Okay, find the angular speed of the fan in radians per minute. That's part A. So 45 revolutions per minute. We want to change that to radians per minute. So 2 pi over 1 revolution or rotation. This is going to be 90 pi radians per minute. And then part B, find the linear speed in inches per minute. Okay, so linear speed is going to be, so linear speed is equal to angular speed, which is that omega, times the radius. So I'm going to take my, we're going to take our 90 pi radians per minute and multiply that by the radius, which is 16. And that's going to give us 1,440 pi inches per minute. And by the way, I should have put 16 inches as the radius, and we did want it in inches. So those are just some practice with circular motion.